You can influence how Code First infers an entity data model from your model classes and creates the database schema in either of two ways, both of which override the conventions. The first is with data annotations. You can decorate the model classes with various annotations that affect the database schema, such as to set maximum field lengths and give tables and columns different names than the model class and property names. These are the same kinds of data annotations that you can use to implement validation in an MVC application, although Code First doesn't use all available data annotations. And then the second way is using the DB Model Builder API. In this case, you could write code that changes how Code First infers a model from your classes using a Fluent API that provides various methods and properties to perform various actions. This option gives you the greatest flexibility for overriding the Code First conventions, but writing the API code is more work than using data annotations. Now, data annotations are attributes on the model classes and their properties, and are much easier to use than writing API code, particularly as your model classes get more complex. The good news is that you can mix and match all three ways of Code First mappings, such as to follow the conventions for most database features, use data annotations extensively to guide the schema inference, and then use the API for the edge cases not easily handled by data annotations. And Code First will apply the rules, which you define, in a specific order of priority. First priority are the mapping rules that you define in code using the DB Model Builder API. So these trump all. Second, it'll apply the data annotations that you place on the model classes and properties. And then third, it'll use the convention over configuration defaults. So if you define conflicting rules using both data annotations and the API, the latter, the API, will take precedence when Entity Framework infers the model from the classes. Now, one of the limitations of Code First is that you can only map classes to tables. You can't map classes to stored procedures or use defining queries, which are defined in the entity data model and are similar to views. Okay, so a bit of a limitation. All right, so let's talk more about these conventions. As I've mentioned, Code First uses convention over configuration to determine the default mappings to the database using your data model classes. A convention is just a set of rules that you can use to configure a conceptual model based on model data class conventions. So, few of the conventions are: Entity Framework looks for a class derived from DB context in order to discover the model classes that you want to use to define the model, and uses the DB set property types to identify the types that you want to be part of that model. Another convention is that Entity Framework will look for a property named either ID or class name ID, and the match is case insensitive, and will make that the primary key for the database table. Every table has to have a primary key, and Code First maps these properties to identity fields in the database. Another convention is that Entity Framework infers relationships between tables based on the navigation properties that you define in the data model classes. And in fact, we'll create a many-to-many table if that's appropriate. And then Entity Framework will create a Code First database or use an existing database for mapping that is located in a localhost SQL Express instance. The name of the database is the fully qualified name of the context object, such as the ordering context class that I use in the sample application. That's in the ordering project, which is in the ordering.models namespace. And so it creates a database, again by default using conventions, that's called ordering.models.orderingContext. You can override where Code First looks for the database and the database name by including a connection string in the application's web.config or app.config file with the same name as the context class. And that's exactly what we did in the sample application. And then another convention is that the table name in the database will be the pluralized form of the corresponding data model class. That's why the database that was created in the sample application had the customers, addresses, an orders table for the customer, address, and order classes. Pluralized it. Okay, so the rules for these conventions are in the system.data.entity model configuration.conventions namespace, and it includes all of the convention definitions. And there's more than 30 of them altogether. All right, so let's talk about using data annotations. As I mentioned, one of the ways that you can override the default conventions is to use annotations on the data model classes to change how code first maps to the database. The .NET framework includes the annotations in the system.componentModel.dataAnnotation namespace, which also supplies additional data annotations that MVC uses for input validation. There's a nice overlapping of functionality there, but code first doesn't use all of the available annotations. So just be aware there's going to be additional ones that you can find in that namespace that don't apply to code first. And then code first in Entity Framework supports a dozen or so data annotations that let you perform tasks such as limiting string lengths, change field names in a table to be different from a property name, change a table name to something other than a class name, create identity primary key fields, exclude a table or field from the database, and to control concurrency. Some of the annotations do double duty when mapping data model classes to an existing database instead of generating a database. In this exercise, I'm going to explore a few of the annotations that code first uses and see their effect on the generated database. I'm going to modify the data model classes in this ordering project in order to change the data types and change the name of a field in a table to be different from the property in the corresponding model class. All right, so all this work is going to be in this ordering model. Now, before I can use data annotations, I want to add a couple using statements, again, just to make my code a little bit cleaner. So I'm going to include that component model, data annotations, that's one, and then I'm going to use an additional section of that data annotations called schema. So between the two, this has all of the annotations that I'm going to use in this part of the application. All right, now, say that we wanted the primary key of the customer table to have the name client ID. Now I created customer ID, but we want to change that for the purpose of the application to client ID. By convention, code first is going to look either for ID or customer ID, the name of the class and ID, and use that as the primary key. So what I'm going to do is change this to client ID. So I'll save that change and I'll run the application. So code first is going to see that I changed the model because it's not going to correspond to what's currently in the database, but I get this exception. And the exception says that one or more validation errors were detected during model generation. And I can view the detail, and I have to drill all the way down here in order to see the message. So one or more validation errors, if I stay on that tooltip, you can see that ordering.models.customer, and unfortunately it keeps disappearing, entity type customer has no key defined. Define the key for this entity type. Customers is based on type customer, has no keys defined. Okay, so the problem again, if I come back over to my ordering model, get rid of that exception, and I'll end execution, is that code first can no longer use the convention of looking for a primary key. And I've not identified another key as the primary key. I don't have an ID property. I don't have a customer ID property, which is the name of the class and ID. And so I need to do something different to identify what the primary key is or the entity key is for this class. Because again, all entities have to have entity keys, which translates into primary keys. All right, so fortunately with data annotations, that's an easy fix. I'm just going to add this key annotation right there. And now we're good. Okay, I'll run the application again. It sees that there's a change, drops and recreates the database, executes the seed method that repopulates it with a couple customers. and causes a problem. Ordering models, oh yes, okay. So the problem here is that everything ran, everything works fine, but now in my views I have access to a customer ID that no longer exists. Okay, so the good news, everything executed, everything worked fine. Except that now I need to change all my views. All right, so I've shown you that. In fact, let's go over to the database here and look at that database there. Go to the customers table, look at the columns, and see that we now have a client ID. So it successfully dropped and recreated the database, changed the customer ID to client ID, set it as the primary key, and if I right-click on customers and select the top 1,000 rows, you can see that the seed method executed, and I have some sample data for the application. Okay, so I'm going to move off that so I don't have any problems with running the application, or at least hopefully won't. Okay, so everything worked, but rather than change all the views, get a little bit tedious, I'm just going to comment this out and change this back to customer ID. Okay, but that's how you would do that. And presumably I would do that when I first created the model, so I wouldn't have to go back in and change any views. Okay, now the next thing I want to do is, if I go back over here to Management Studio and drill back down in here, notice that all of my strings are n varchar maxes. That's the default for code first. Code first just assumes the worst. It doesn't know what a first name is. It doesn't know what an email is. It doesn't know what those things are. It doesn't have that kind of intelligence built into it. So it just assumes the worst, that it needs the maximum amount of room to store strings. But that's pretty inefficient as far as the SQL Server database goes. So the next thing I want to do is change that so that the individual string fields for these objects have more realistic data types and lengths. All right, so I'll go back over here and back over to my model. Okay, so what I can do is I can use the min length and max length attributes to control the string length. So customer ID I don't need to do anything with, it's an int. But for the first name, I'm going to set this to a max length of 20. Reasonable length for a first name. I'll set last name, max length, to 30. Last names tend to be a little bit longer. And I'll set the company name, it's an attribute of max length, of 120. People sometimes get carried away with their company names. Email, longest an email can be is 225 characters, so I'll set that to the max length. And then I'll set, for the phone, I'm going to set both a min length and a max length. So this is an application. It's going to store United States and Canadian phone numbers, so that's a standard format. So I'm going to do a min length, minimum length, of 10. So if I just have digits, and then I can add a second annotation either by adding a comma there within the same brackets or just add another attribute in a separate set of brackets. So I'll do a max length here of 15. So if I include all the punctuation in the longest case, the maximum length is going to be 15. Okay, now I'm going to keep things relatively simple. I can get a lot more complex. For example, I could add a regular expression data annotation to the email property and specify a regular expression to force users to enter only valid email addresses. This would have no effect on how code first generates the database. But application types such as ASP.NET MVC can make use of that kind of annotation at runtime in order to validate user input. Okay, also there's a string length attribute that lets you set both the minimum and maximum lengths, but the syntax is a little bit funky, so I think the code is just clearer with min length and max length, using them both together. And then I can also add an error message argument to each annotation in order to customize the error message presented to the user at runtime when any requirements are violated. But code first doesn't make use of those messages. That's just a user interface for MVC. So my point here is that you can really get carried away with data annotations that have purposes that go far beyond what code first can use. Okay, I want to go a step further with my customer model here, and I want to make the first name, last name, and company properties required, or in database speak, non-nullable. And for that, I can use the required attribute. Okay, so to keep things clean, I'm just going to add a comma here and specify required. For the first name, I'll do it a little bit different notation here, just to show you the difference. So that's an alternative. That's going to have the exact same effect as the required on first name. And I'm going to make the company name required as well. Okay, so now those are required. And that's going to be enforced by code first because it's going to make those fields in the database non-nullable. And then MVC can use that to say, hey, you have to enter something for the first name, last name. Right, another thing I want to do is say that I wanted the created property here to still be called created here within my class for the sake of the application, but I wanted the field in the database to be called first contact. So for that, I can use the column annotation and specify first contact. Okay. So typically I'm going to do this in a situation where I'm using code first with an existing database, where my application needs to have the domain of the application uses different names than what the database creator used. But I can use it in code first as well. And now it is when I'm creating the code, not using it with an existing database, I'm going to recreate the database, and it's going to be called first contact. Okay, so whatever reason you might have for doing that. All right, and then the other thing is, say that I wanted to do a similar thing with a table. So here, say that I wanted to map the order class to a table named sales order in the database. And for that, I can use a table attribute. And I'm going to call that sales orders. Okay. And notice that I'm making it plural. Okay, so I'm specifying what that name is. So no matter what my policy is with pluralization, this table is going to be pluralized. Okay, so that's all the changes I want to make. I'll run the application. It'll drop and recreate the database because it sees that I made changes to the schema. And hopefully my having Management Studio won't cause this to not run. Oh, because it's currently in use. Oh well. Okay. Usually it's not quite that persistent, so I'm just going to close that window, and that way I'm more or less guaranteed that it's going to happen. Okay, so now it should be dropping and recreating the database with my different schema. All right, so the seed method ran, so I have my data. I'll fire up Management Studio again. Go down into my database and my tables. Okay, first of all, notice that I have sales orders. This is the order table, has order information in it. I didn't make any changes to the properties of that object, just change the name of the table that it's mapped to. And then in customers is where I made most of the changes. Okay, so notice that the first name is now an nvarchar 20, last name is 30, company 120, email 225, phone is 15. It's only using the max length. There's no, well, there are ways, but there are constraints. There are ways of doing it, but essentially for the purposes of code first, it's setting the maximum length of that phone. And then it changed that field name to first contact, even though the name that I need to use in my application here is still going to be the created. Okay? So be clear. Application is created. In the database, it's first contact. Okay, and by the way, the view appeared because of all the changes I made, none of them changed the field names of the properties. And so I'm still able to get the first name, last name, company, email, fields, and so forth. The one change that I did make that would have broken this, and in fact we saw that it broke, is changing customer ID to client ID, but I reverted, I undid that change. Okay, now I can click on the Create New, and without entering any information, I'm going to click on the Create. And notice that because I included those annotations, this is an MVC thing for the user interface, it picked up and hooked into the default validation handling for those individual fields. And because I named first name, last name, and company required, and created is required just because date time is not nullable, I get these error messages. And so you can see that MVC is making use of those same data annotations that Code First was able to make use of when it recreated the database. Okay, and so I can do things like enter super long fields, and now I've exceeded the maximum length. So the field first name must be a string or array. I'm good there. With a maximum length of 20, I've exceeded that. Same thing here. If I go too far beyond 30 this time, then I get the same error message. Okay, I'll go back here. I'll enter some real data. Company is required, so let's say John is with LearnNow as well. And I'm going to enter an email of, well, I didn't validate this, so this can be anything as long as I in fact don't have to have anything in there. And then the phone is not required, so I don't have to enter anything. But if I do enter anything, I need to enter at least 10 characters. Okay, so that's not long enough, so I'll do actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay, so that's good. I can enter 1, 2, 3, 4, 5, and that's good. But as soon as I go too long, now I've exceeded the maximum length. So you can see how that validation works with an MVC application. And then similarly, if I go ahead and do that and create a date, so I'll do 12/31/2017 for the created date and execute create, notice that it just redisplays the view with that validation error showing still. All right, I'm going to end the application, go back over here to Management Studio, and you can see all those changes that I had made. Okay, I already covered all that. Okay, so now I guess I'll close this just so I don't get into any problems again. Now, say that you want to create and use the database in a default instance of SQL Server, but give it a different name. And specifically, I want to name the database Ordering System. Okay, now, in a regular application, probably up to this point, I'm using SQL Express if it's installed, or LocalDB. I've gotten the database where it's reasonably stable. I want to now deploy it to a test server or development server, however you're set up. So now I can go over into web.config, and I had previously created this connection string with the same name as my order context to use the default instance of the full version of SQL Server, in this case SQL Server 2014. And I initially gave it the same name as what would have been created in SQL Express or in LocalDB. But now I want to change the database name. So I'm going to use this. It's going to be Ordering System. Okay? So there's that change. Okay, and one other thing to point out about this connection string. If you've looked at other videos within this course, particularly when I've talked about database first, you may recognize that this is just a plain old ADO.NET connection string. It's not a full entity framework connection string that specifies the different models that are part of the entity data model. Because we don't have an entity data model in this application. It's being inferred and done in memory. There's no .edmx file. If I come over here to Solution Explorer and look at my models folder here, all there is this ordering model. And I can expand that, and you can see the different classes that are included. There's no .edmx file here. Okay, so I don't need that full-blown entity framework connection string. Okay, because I don't need those XML files, and I don't need any of that. So I'm going to run the application again. This time, it's going to run. I'm going to look for a database called ordering system. It's not going to find one in the location I specified, which is the default instance of SQL Server 2014. And so it's going to create the database as though no database ever existed. And as you can see, I have the 2 customer records because the seed method ran, because that runs both when you create the database and recreate it. And now if I come back over to Management Studio, start it up again, connect to my local host, notice that I still have my ordering models.ordering context. As soon as I changed that connection string, that application forgot what this database was. Ordering.models.ordering context, what's that? So it ignores that, just like it's been ignoring the AdventureWorks database, the Northwind database, the reporting services databases, and so forth. All it did is it went, looked at the database, saw that there wasn't an ordering system, and created ordering system. And here's our database. Has all of the tables, has the changes. Sales orders is still called sales orders. Customers, addresses, and so forth. The many-to-many table, as well as this migration history table. So it's all there. We've moved to a new database. And I just as easily could have changed the server name to deploy ordering system to a different server. Whatever you want to do.